The human brain is incredibly efficient at processing concepts. You can recall a specific destination, understand its purpose, and know exactly what it represents without ever needing to know its precise GPS coordinates. But ask us to memorize a 10-digit string of disconnected raw numbers, and our cognitive system immediately struggles. We are wired to remember intent and meaning, not abstract mathematical sequences. That creates a problem when we look at the actual architecture of the internet. Underneath the familiar interfaces, every website and server is part of a rigid desert built entirely on exact mathematical coordinates. If we had to interact with the internet in its raw state, visiting a daily news site would require manual entry. You wouldn't type a name. You would have to recall and enter a complex 10-digit numerical code every single time you opened your browser. For the internet to evolve into a tool for the general public, it had to overcome a structural friction. A network built on math was being navigated by people built on concepts. Computers require absolute precision, routing data through a cold, exact structure. Every device gets a numerical spatial coordinate, the IP address, like 142.250.196.110. Computers don't understand human intent or a sweet honey nest. Human text physically bounces off. The system only recognizes numbers. This creates a direct conflict. Human users want to navigate by names, while the computer infrastructure can only route by coordinates. Without a bridge, every digital interaction would stall at the point of entry. To use the network at all, humans would have to abandon the way they naturally think and speak, limiting the web to those willing to manage a personal ledger of thousands of numerical codes. Think about the simple action you take whenever you want to find information. You type a recognizable name into your browser bar and hit enter. That recognizable text is a domain name. It serves as a human-friendly mask placed over the machine's true, shifting destination. The system designed to bridge these two halves is the Domain Name System, or DNS. DNS does not store the websites, the videos, or the text content itself. Its sole purpose is to act as the master directory of locations. It functions like an address guide in an ant colony. If an ant wants to find the sweet honey nest, the guide maps that abstract request to an exact physical location, directing them to the forest's east side, third tree, basement level 2. DNS is the mechanism that maps human intent to machine reality. It allows both sides to speak entirely in their native languages. To see how this works, we have to look at the microsecond immediately after you hit enter. In this sequence, you can see the user's device on the left. It pauses its connection attempt and fires an interrogation signal to the DNS directory in the center. The DNS scans its global ledger, cross-referencing the human word with the machine coordinate. It locks on to the specific string, 142.250.196.110. The DNS then fires this numerical IP address back to the user's waiting computer. Armed with the correct mathematical coordinates, the user's computer can now establish a direct connection to the destination server, bypassing the directory entirely. This entire interrogation and translation happens in milliseconds. The complexity of the process is entirely hidden from the user. This exact translation sequence occurs billions of times every single second across the globe. Because of this architecture, the web is highly fluid. A website can change its server or its IP address on a daily basis, and your experience of the domain name remains completely stable. DNS represents the moment we priority mapped the network. We didn't force humans to learn the language of machines. We built a layer that allowed the machine to understand us. The internet remains a network of raw coordinates, but because this translation layer exists, we can navigate that sprawling infrastructure using nothing more than the words and names we already know.